Hello guys, in this video I would like to explain about machine learning, and first we will explain machine learning theoretically, and then I will explain this in Python, that how you can perform a particular machine learning algorithm in Python. And this is the new playlist which I am starting today for my channel, and the title is machine learning. So this will have explanation detail of different machine learning algorithm, and we will start from very basic simple linear regression analysis, and we will show that how we can call this a machine learning, because some people maybe not agree, but after this video you will be able to understand, yes, this is a machine learning. So we will have brief detail about the theoretical background and the theory about how this particular machine learning algorithm works, and then I will explain that algorithm in Python as well as in R side by side in different videos. So if you like to use Python, you can follow that video, and if you want to do that in R, you can do that in R. Yeah, it's up here. They have different, positive and negative points, but whatever you want to follow, you can follow each of them in one of them as you like. And the theoretical is of course the common, so you can see how these algorithms works. This is very important, and nowadays this is a lot of application almost in every area of research. So the purpose of today's video is to see how this we can say simple linear regression is a machine learning approach. Okay, so let's move to the PPTs, the slides, that how we can say this is a machine learning. Just look at this. This is the simple model for linear regression, simple linear regression. Simple linear regression means that there is one dependent variable y and there is one independent variable, that is x. And this is actually the estimated model when there is like this hat and this y. This means this is the estimated or predicted value for y, and of course the ith value. This is the intercept. This means that this is the value of y when there is no contribution from x. I will show this mathematically when I have my tablet, graphic tablet. So I will draw. I will show you, by just writing. So it should be more clearer. And this is the coefficient of this x. This means that beta 1 is the contribution of x. I mean, this is the change in y given the per unit change in x. So b1 represents change in y given per unit change in x. As we change x, this is the amount of change. b1 is the amount of change in y. b1 is the amount of change in y when we change x. And this is the values of independent variable. These xi represent the values of the independent variable. And this graph you can see, this is the predicted model. So this is the predicted line, estimated line or predicted line is this green line, and these are the data points, the black dots are data points, and the difference between the line and the point, data point, this is called error, or you can say residuals or random error. Usually in the regression model, we are including this. In the simple linear regression model, we are including this one independent variable, but there may be other variable which influence y, and we are not including that, so that's create this random error. So this is the error term. And of course, when the line is far away from these data points, there will be more, there will be higher values of error term. And the least square method, the method which minimize the sum of square of the residual. So this the method which reduce the error, of the estimated line and the data, the observed data. Now let's move at how you can call this as a machine learning simple linear regression. Linear regression is often considered as a machine learning algorithm because it fits the criteria and principle of ML despite its root in statistics. Here are some reasons why linear regression is categorized under machine learning. So that means that why we call this as a machine learning. So these are the reasons. You can give, someone ask you, you can give the reason that's why we call this as a machine learning. Prediction and generalization objective. Like other ML algorithm, the primary objective of linear regression is to make predictions. It learns from historical data, training data, to predict outcomes for new unseen data, test data. We will do this in Python as well. So this means that if you go back, just look at this. This is the estimated model. You have a data for training period, 30 years, 50 years, whatever, and you estimated beta naught and beta 1. So this is something learning from the data. Now you want to test this y, the response variable, for the next values, which you don't have these values, but you have the values for xi. You have the values for independent variable. You just need to provide the values for independent variable, and the model will use the parameter beta naught and beta 1, which have the values from training data, and will provide you y variable. So this is what we say prediction for the test data for the unseen response variable. So this is one point. Generalization. Linear regression models aims to generalize well to new data, which is a core principle in machine learning. So this is the same thing, almost the same thing as we have talked objective. So yes, we generalize from to the new data, like the test data, or you can estimate the response variable y variable as long as you have the values on the independent variable and the predictors. You already have beta naught and beta 1 from the training data. That's something you can say learning. Learning from the data is the same thing. Linear regression involves a training process where the model parameters, weights and intercepts are adjusted to minimize the error between the predicted values and the actual values in the training data. This is akin to the learning process in other ML algorithm. Here, this is very important. When you are using regression analysis, just go back. When you are using regression analysis, you are using least square method to estimate the unknown parameter beta naught beta 1, and you are trying to minimize this error, the error between this straight line and these values. So this is something you are learning from the data and try to minimize this error. So this is something like this. You are adjusting this weight, and I will explain, I will drive these values as well, the parameter, maybe some other time in the video, that how we can use these values to minimize this error. So that's something you are adjusting these parameter there. You are learning from the data. You are using the data and learning from the data to minimize the error between the predicted values and the actual values. And this is one of the core principle of machine learning. Error minimization, again almost the same thing. We are trying to arrive to a conclusion that we have the reduced sum of squares. The model learned by minimizing the cost function. Remember, this is the one of the core principle of machine learning, cost function. And in linear regression analysis, we are using mean square error, sum of square, residual sum of square. So we are just trying to use this to reduce this error, which is a common approach in machine learning to optimize the model. So the same thing we are using in the simple regression analysis as well. Algorithmic approach. Algorithmic nature. Linear regression is an algorithmic approach to finding the best fitting line through the data point. This systematic approach is to learning from the data and making prediction fit well within the ML framework. Yeah, so again the same thing. We are trying to fit to minimize the error and draw the line, estimate the line which is the reduce error. So this is you can say an algorithmic approach, like which is also in the machine learning. Supervised learning, label data. Linear regression is a supervised learning algorithm, meaning it requires label data to learn from the relationship between input features and dependent variable and the output dependent variable. Yes, so we need data on independent and dependent variable, and we just try to establish a relationship. The model learn from this relationship and try to reduce the error. And yes, so label mean this is a supervised learning. You have data on the dependent variable as well, and unsupervised mean you don't have to do this predictive relationship. You are just trying to find some pattern and structure in the data. Regression task. It specifically address regression task, predicting continuous outcome, which is a key area of supervised learning in machine learning. Remember that if you know about SVM, random forest, artificial neural network gradient boosting machine, those models can be used for classification as well as for regression purpose. So regression purpose, simple linear regression is of course we use this for regression purpose, and machine learning also have this purpose, one of the core purpose, regression. So this is again in the machine learning class. Application in ML pipelines. Features engineering. Linear regression can be a part of more complex ML pipelines involving feature selection, processing, and other ML algorithms. Model evaluation. Techniques such as cross-validation, regularization, e.g. lasso regression, ridge regression, and performance metrics, e.g. root R square, MSE, mean square error, used in linear regression are also fundamental in other ML models. So this is again sharing the same point. Scalability and automation, you can use this for this purpose as well. And integration with the ML framework, linear regression is integrated into popular ML libraries. Okay, the same like like these libraries. So this is also integrated in this. So this means that overall we can say that regression analysis simple. Of course, this video is about simple linear regression analysis. So this has many things which is the important point in machine learning algorithm. So we say that this is a regression analysis, but we are unaware normally, and we are, and the other thing is we are just learning this from very beginning. So we don't know it. This is the concept of machine learning. This is the machine learning, and this is the one of the first. I mean that you can say very easy and the first step in the machine learning. So you just start it because all the properties which the machine learning has, you can see in the regression analysis, in the simple linear regression analysis. So this is all about the theoretical part, that why a simple linear regression is in the category of machine learning. So these are the reasons. And what is the procedure which we'll do in Python? Require data, identify the suitable model, establish, estimate the parameters, diagnostic checking of the predicted model, predictions. So you can do predictions, and so these are all the steps which you can use. I will not do all these steps as I have done this once already, and the link to that video is given in the description of this video, so you can just click and watch, and you will see how these steps work and how I did these steps step by step. Today I will just show you that how the simple linear regression work generally, not by doing these steps step by step. For this purpose, okay, one thing more that if you want to know what is machine learning, just Google it and you will see. Simply put, machine learning allows the user to feed a computer algorithms with the immense amount of data and have the computer analyze and make data-driven recommendation and decision based on only the input data. So this is the same thing as we have explained. So if you want to know more, you can just Google it and you will see more things. Now let's move to Python and how we can just try there how we can do this machine learning. The simple linear regression is a machine learning in Python. You need these libraries, NumPy, and now this is for plotting. This is for to train test split. This function will split the train and test data, and then linear regressions from this library. You will need this, and then mean square error and R square score from this library. We will need this function as well, so you need to. Now this is just in generated data, as we have done in the start of the Python when we started, how we can generate this data. And now this is x, the independent variable, just to multiply by this random number generation, 1000 of values, and you can see this is x. You can generate these values from a specific distribution. You need to mention the name. You can see my videos, the previous videos on Python in the playlist data analysis with Python. So we have now two data sets. You can plot this data by using PLT scatter xy, and you can see the relationship of the data. And I will explain a bit about their data as well. So let's look at this. Look at this data. What you see in this data, just look at this. This is x axis. Better to plot this full plot, then you will see the x axis and the y axis as well. So let's do this, x axis and y axis. So look at this, x is increasing, y is increasing. Look at this value is 4x, so almost 0, and y is something like 2, and here is x is around 2 and y is around 11 or something like this. So as x is increasing, y is increasing, so this means that there is a positive relationship between the two data sets. This means y depend on x, but this relationship is positive increasing, so we will have the regression coefficient as a positive value. You know, this value should be a positive value, so you can just guess from the data as well. This value should be positive value beta 1, the coefficient of the x. Okay, so you have data. You already have data. You have prepared the libraries, the functions. You need now to estimate, to test the data, and to train and test. So this is the function train, test, split. So this will split the data of the independent variable x and the y dependent variable and test size as 0.2. I explained this term already, so you can go and watch my previous video. So this is about randomness. So this is 20% to the test, and 80% data will allocate to the training period, and x train will have train data for the independent variable, x test will have data for the test for the independent variable, y train and y test will have data for training and test of the dependent variable, and this will be assigned by using this function. Just click at this. Okay, so this is working. Data is distributed into train and test. Now we'll just create the model, linear regression. The syntax will look like this, and now fit the model. Okay, so we have fit the model now, and now you can do prediction. So we have done all the steps to minimize the error, to find the optimal values of intercept and the coefficient of the regression of the independent variable, and minimize the error. And now we are doing prediction with that. For the test period, remember, we have we have this y test. These are the original values. Remember, these are the original values of the dependent variable, and now we are just trying to predict here to predict y based on the independent variable values. Just put x test and model.predict, apply it to x test data, and you will have y values. Okay, now we have predictions, you have actual values, so you can calculate MSE and R square. This is the R square, mean square error, y test and y pred. So this is the original values and this is the predicted values, and similarly R square is the actual values and the predicted values. Just look at this. Okay, now print and print as I already have done this. So this is the way, this will give you the value, and this is the text which will be printed. And similarly here for second, just do this. Yeah, so the mean square error is 0.777 and the R square is 0.79, which is, yes, which is okay, not very high, but it's fine. So this is something which we wanted to do. Now if you want to plot the actual value, if you want to plot the actual values, and then you compared the estimated value with the y, you can do like that, but we can do like this. So this is the plot which will have the scatter plot of the x test and y test. Just look at this, you will see like this. This is the test data, remember, and this is x and this is y, and you can plot the fitted values with this, the same data. Like I will combine this, these are the labels, you can see like this. Yeah, so this is something like this. These are the scatter plot of the x and y data. Remember, this is for the test period, and these are the fitted values. So we just try to minimize the error between the line and the data points. So this is the minimization which we have used cost function as mean square error, remember, and you saw also the mean square error. So these are all things that which fall in the machine learning framework. Remember that with this function you cannot print the summary. So I'm using the other, this package, this library, and I'm estimating the model, and then again I will show you the summary of the model here, and you will see the beta coefficient is positive. Okay, it's not working. I will see this. I'm going to sort out this, but remember that this coefficient should be positive because you can see the relationship, it is increasing. So if it's in the reverse order, if you can see, if this plot, if this plot is in the reverse order, like starting from here and going like here, then the beta should be a negative value. So this is something different than this. This is the inverse of this. So this is all about machine learning, the simple linear regression analysis. How we can present that simple linear regression is a machine learning approach. So this is all about the theory, and then with the Python, how we can do this in the Python. So I hope you are able now to convey that simple linear regression analysis is a machine learning approach, and this is one of the simplest machine learning approach. You can argue and you can convince someone with the evidence. If you have any question and confusion, you can write me in the comment box of the video. And if you want to know about the steps which I showed here, the end of the presentation like this, you can watch my video in which I have done these step by steps. The link is given in the description of this video. So I think this is enough for today, and thank you very much, and see you in the next video. Ciao.